Okay, welcome back. I think I've got everything ready so that we are able to go through and do this one. Um, so, uh, we're going to go through and do the Kruskal-Wallis test. There's a link on here. You can see there's lots of links out there on the internet on how to do these different tests. And again, as I said earlier, if you have access to the mini tab, you can do that. The main thing is I'm not asking you to do the calculations. We will do the calculations with some small samples just so you can see how it works. But don't try to do this with anything that's larger. Find a computer program that allows you to do that. So let's go to an example here. This is one that you should have access to. It's the data that's in table 13.9, the textbook, and so we'll calculate the test statistic, and hopefully I get the same answer that I got that's in the table. I mean, that's in the book. I've already put in some of these values, the 3, the 6, 16, 26, 27, and this column in. Let's go in and put in these 4. I'm just hitting the enter key after each one of these. These samples are the same size, but they don't necessarily have to be. And then let's click on calculate. I'm going to scroll back up here, and it gives the ranks for each one of these and the sums. It calculates the statistic of 1.58, which is really encouraging to me, because that's actually the value that we calculated down here, so that's good. And you can see I did this by hand, but it's good to have the computer verify what I've done. And then, again, you may not be able to see this, so let me just read it. The Kruskal-Wallis test is not significant, and it does give some non-parametric Bonferroni type multiple comparisons, but since it's not a statistical significantly difference, then we're not going to pay attention to that. So let me, at this point, I want to go back and pick up some of the information that was on the previously recorded video. It does have to do with the next test that we were going to study, the Spearman's rank correlation test. And then when that finishes, we'll come back and actually do a statistical test with it. Okay, another test is the Spearman's rank correlation, and these are used when you have paired observations and you want to find the relationship, you want to find the association. We talked about the Wilcoxon test for max samples, for paired samples. That's used if you want to find a difference between these two groups. Spearman is used to find if you want to find a relationship or an association between those two groups. Okay, just a quick example here. We go through and figures out how to play a video game. They have a real sharp learning curve, and then they sort of slow down and they level out. Okay, but you can see that the number of games played plus their score, I mean, it's going to max out up here because they can't get any higher than that score. But that's going to be a non-linear type of relationship. If you analyze this with a parametric test, it's going to try to fit a curve that goes through here, and it's not going to have a very good relationship. But since we're using ranks, this is ranked 1 on this scale, 2, 3, 4, 5, 6. You know, those ranks are going to match up pretty good because we do throw out the magnitude values. And
we'll actually get a better correlation with the Spearman than we do with the Pearsons in this particular situation. Here's the calculation. Again, there's plenty of tests. If it's a nonlinear relationship, then the Spearman correlation is going to be higher than the Pearson correlation. And so sometimes you can do both of them, and then you can see how that works out, how it works out a little better.
Okay, so I'm going to break in at this point, and we're going to go to the rank correlation coefficient test. And there was a link there right here that this is the particular one that I'm using. May not even be able to see the little arrows there, but so what we're going to do is we're going to analyze this data right here. This does have a relationship, and that relationship is a y is equal to x squared. But it's not a linear relationship. A linear relationship would, sort of go like this. And so the Spearman is going to be do a little bit better job of finding that relationship than the Pearson. Since this is, the ranks are 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. This should give us a perfect relationship. But if you go and you plug these values into a Pearson's correlation, you're not going to get a perfect relationship because it's looking for a line so let me just plug these values in here. Again, it's a whole lot easier to do it with a program like this than to go through and try to do the calculation. Again, all of these, there is a definite one-to-one relationship. There's a formula that is used to calculate all these values, and we're just trying to go through and just give you a quick example here. One less value here, and we don't need those guys. And submit, and we find that the R value is 1, N is 7, the P is significant. So this goes through and says that there is a relationship between those. If you were to go through and do this with the Pearsons, you get something that's less than a 1. So the point is that in a Spearman's correlation, if it's a nonlinear relationship, you can still get a value of 1 for the R value. Okay, and then one last thing that I do want to go back to, and we've talked about this before, and this is in the Moodle site, and in the Moodle site we've got a statistical test table. This one's in topic 13 there. Again, these are the tests that we've talked about today. The Wilcoxon test, the Mann-Whitney test, Mann-Whitney sign test, Kruskal-Wallis test, Spearman. We did briefly talk a little bit about chi-square and those kind of things in relationship to some of these, but these are the non-parametric tests that we've talked about, and they're very useful. Okay, so that's all I have for today, and this is the last one of these. Hopefully